Welcome to today's webinar, Introduction to Deploying Applications on AWS. Our presenter today is Warren Sentner. Warren is a Senior Solutions Architect in AWS worldwide public sector, working with strategic enterprise customers and education technology partners. He has been focused on assisting customers adopt DevOps principles and implement services such as AWS Elastic Beanstalk, Amazon EC2 Container Service, AWS Lambda, and Amazon API Gateway to streamline their development workflow and improve operational efficiencies. Today with us, we also have Will Sinclair, Solutions Architect at AWS, and Leo Chatnovsky, Principal Solutions Architect at AWS. Will and Leo will engage with you and answer your questions throughout today's presentation while Warren presents. Warren, welcome. I now pass the floor to you.
Thank you so much, and hello everyone. As Bowen said, I'm Warren Santner, a Solutions Architect with Amazon Web Services. I'm really excited to be here today to introduce you to 3 flexible services you can use to deploy your applications on AWS. We have 3 primary objectives today. We'll start by scaffolding our conversation from an introduction of the 3 primary services used for deployments on AWS up to a quick technical overview of each service, while discussing the use cases and strengths of each service throughout the webinar. If I were to summarize our objectives, though, it would be this. You'll be able to leave the webinar today knowing which service best fits your specific use case and application, and will be able to try it out on your own. We get a lot of feedback from our customers, and they're telling us how they've been able to innovate their businesses in new and exciting ways thanks to the agility, the elasticity, and breadth of features available on the AWS global infrastructure. Some of our customers, though, find that their legacy deployment methods do not match the agility they're getting running their workloads on AWS. Perhaps you can relate to the fragile, high-touch deployment processes that can cause downtime for your users and keep your operations teams up at night. These technical challenges probably come as no surprise to any of us here today. I'm sure many of us have devoted our nights and weekends to rolling back a failed deployment or trying to successfully redeploy after an infrastructure failure. These challenges have a material impact on your operations as well as the developers, operations staff, engineers, and all the folks involved in keeping business-critical applications running. Fortunately, computing in the cloud shifts the paradigm, making it easier to reliably deploy your applications. Leveraging AWS services for deployments provides several key benefits. Agile deployments are becoming more and more important today. Time to market is key. As the software development lifecycle has moved from waterfall processes to agile models of development, these improvements must move downstream to deployments as well. You can leverage AWS services for deployment of applications that are more reliable, predictable, and efficient. Flexible options are important for our customers as well. From code to container, from one instance to thousands, from EC2 to on-premises, AWS deployment services are extremely flexible to solve for both the simplest deployment scenario to complex deployment orchestrations at scale. And speaking of scale, scalable capacity is important as well. If you want to leverage auto-scaling to horizontally scale your capacity to meet your application demand while being cost optimized, you don't want to be worried about scaling your deployment service. Let AWS manage that for you. From a single server deployment to thousands of containers, AWS Deployment Services will scale to meet your demands. And finally, automation capabilities are really important to our customers. If you need to SSH or RDP into your servers, your deployment process really isn't optimized. IT operations need to deploy applications in consistent, repeatable, and reliable manner. And leveraging the automation capabilities of the AWS Deployment Services allows you to build out your DevOps tool chain as you continually improve your internal processes. AWS offers 3 flexible services to help you manage your application deployments. First, we have AWS Elastic Beanstalk, which enables our customers to deploy their applications in minutes without having to manage the underlying infrastructure. Next, you can choose to use AWS Code Deploy to flexibly automate deployments to both Amazon EC2 and instances running on premises. Finally, we have Amazon EC2 Container Service, often referred to as ECS, which is a scalable cluster manager for Docker containers that lets you flexibly schedule and update your Docker applications. The AWS cloud infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. And these 3 services are no exception and provide great flexibility. And it's likely that your applications or deployment pattern could be implemented in 2 or even all 3 of these services. That being said, each service has specific strengths for particular deployment patterns. If you are brand new to AWS, then Elastic Beanstalk really is the best way to get started deploying your code or container without managing the underlying infrastructure. Developers simply upload their application, and Elastic Beanstalk automatically handles the deployment details of capacity provisioning, load balancing, auto-scaling, and application health monitoring. AWS Code Deploy, though, is a little different. It's a service that automates code deployments to any instance, including Amazon EC2 instances and instances running on premises. AWS Code Deploy is a building block service focused on helping developers deploy and update software on infrastructure they already provision and manage. Amazon EC2 Container Service is a highly scalable, high-performance container management service that supports Docker containers and allows you to run your applications on a managed cluster of Amazon EC2 instances. Amazon ECS eliminates the need for you to install, operate, and scale your own cluster management infrastructure. You can work with Amazon ECS directly if you want more fine-grained control of your custom application architectures. Before diving a little deeper into each service, let's look at some customer use cases that fit really well with each service and discuss why the service would excel at that deployment pattern. In our first Elastic Beanstalk use case here, we have a user that is really focused on the business value they get out of an application. They have outsourced the development of this application and are not interested in the intricacies of provisioning the building block services, such as the Amazon EC2 instances, the Elastic load balancers, the auto-scaling groups, etc., to support their application. Elastic Beanstalk is a great fit here because the customer can simply upload their WAR file, and Elastic Beanstalk will handle the deployment details and provide the end-to-end management and monitoring capabilities for their application. Let's skip to the first code deploy example here. Here we have a situation where a customer already manages the provisioning and monitoring of their infrastructure, including their application servers, load balancers, databases to support their application. This customer wants an architecture-agnostic deployment tool that will allow them to use scripts from their custom deployment process while still orchestrating rolling updates across their fleet. Code Deploy is a great fit here. It will allow the team to integrate with auto-scaling as well to optimize the efficiency of their application. Finally, let's take a look at one of the Amazon EC2 container service examples. In the first example, we might have an organization with dozens of development teams moving to Docker as their unit of deployment. The operations team needs a custom platform for complex application architectures. ECS is a really good choice here because it provides fine-grained control, but without the burden of building, operating, and scaling Docker cluster management infrastructure. As we've looked at these three use cases, hopefully you're starting to think about how your application or use case might best fit with a particular service. Let's start now by diving a little deeper into AWS Elastic Beanstalk. AWS Elastic Beanstalk really is the fastest and simplest way to get an application up and running on AWS. You can simply upload your application code and the service automatically handles the details of resource provisioning, load balancing, auto-scaling, and monitoring. Elastic Beanstalk is ideal if you have a standard application stack that can run with an app server or app servers and a database. Let's look at some of the benefits. As we've been discussing, it's really fast and easy to get started with AWS Elastic Beanstalk. This leads to improved developer productivity, so your developers can really focus on writing code rather than spending time managing and configuring servers, databases, load balancers, firewalls, and networks. With this ease of use, you do not sacrifice scalability or control though. So you still get the ease of use, but if you want to scale, Elastic Beanstalk can automatically scale your application up and down. You also retain full control over the AWS resources provisioned to support your Elastic Beanstalk environment, with the ability to take over any or all the elements of your infrastructure if you need to. Let's take a look at how the AWS Elastic Beanstalk service works. The service provisions the EC2 instance or instances with the proper operating system and application and web server software to support your code, so you don't have to worry about installing and configuring servers and can instead focus on your application. There is no need to SSH or RDP into your server to set up your application environment. Just focus on your code and your application. That code that you're now really focused on because you're no longer worried about the end-to-end management of the infrastructure can be written in Java, .NET, PHP, Node.js, Python, Ruby, Go, or packaged in a Docker container. And although the service is ideal for web applications, because of Elastic Beanstalk's open architecture, non-web applications, perhaps an application that is processing data that is fed to it via a queue, can be deployed using Elastic Beanstalk. There's a lot of flexibility in the platform here. As you're building and iterating on your application, you'll probably be generating new releases, new versions of your application. AWS Elastic Beanstalk allows you to easily manage different versions of an application. In AWS Elastic Beanstalk, an application version refers to a specific labeled iteration of deployable code. An application can have many versions, and each application version is unique. And in a running environment, you can deploy any application version you already uploaded, or you can upload and immediately deploy a new version. You might upload multiple application versions to test differences between one version of your application and another. In AWS Elastic Beanstalk, an environment is a version that's deployed onto AWS resources. Each environment runs only a single application version at a time. However, you can run the same version or different versions in many environments simultaneously. When you create an environment, Elastic Beanstalk provisions the resources you need to run the application version you specified. With multiple application versions and environments, you can easily deploy dev, test, staging, and production environments, perform A/B testing, or orchestrate blue-green style deployments. Elastic Beanstalk environments are very flexible and can be configured to match your use case and scale appropriately. Perhaps your development environment only needs a single instance of the application version you're testing. There is no need to scale. On the other hand, your production environment on the right here can use an elastic load balancer and auto-scaling to meet your application demands. There's also a lot of flexibility in how you can handle deployments within your production environment. AWS Elastic Beanstalk has the flexibility to support rolling updates. You can deploy your application versions in batches. Or as previously mentioned, you can orchestrate blue-green style deployments by leveraging two environments and swapping your CNAME DNS records. Hopefully you've seen as we dove in here the flexibility but also the ease of use of starting with AWS Elastic Beanstalk. Now let's dive a little deeper into AWS Code Deploy. AWS Code Deploy is designed for developers and administrators who need to deploy applications to any instance. As we've talked about, these instances could be on Amazon EC2 or running on premises. It's flexible and can also be used by anyone wanting to update software or run scripts on their instances. It does not, though, provide the end-to-end infrastructure provisioning management capabilities that are found in AWS Elastic Beanstalk. Let's talk about some of the benefits of the Code Deploy service. First, AWS Code Deploy fully automates your code deployments, allowing you to deploy reliably and rapidly. You can consistently deploy your applications across your development, test, staging, production environments. And the AWS Code Deploy service will scale with your infrastructure and integrates nicely with auto-scaling so you can deploy to one EC2 instance or thousands. AWS Code Deploy helps you maximize your application availability by performing rolling updates across your Amazon EC2 instances and tracking application health according to configurable rules. Deployments can easily be stopped and rolled back by redeploying if there are errors. AWS Code Deploy also allows you to easily launch and track the status of your deployments through the Management Console or the AWS CLI. You get detailed reporting, allowing you allowing you to view when each application revision was deployed and to which instances. Finally, our management console and tooling makes it easy to adopt. Let's take a look at the workflow to coordinate automated deployments with AWS Code Deploy. There are 3 basic steps. First, you'll build an application revision that defines how you want your application installed on a single instance. Next, you'll prepare and specify the targets you'll be deploying to. And then finally, you'll create a deployment, associating your application revision with your deployment group and specifying how you want the rolling update to be orchestrated. Let's take a look at each step in a little more depth now. The first step is to package your application up for deployment. You need to define how to install your application on a single instance, and you use what we call an app spec file to do that. This file is what provides the extreme flexibility that enables Code Deploy to work with virtually any type of application. You specify where you'd like files copied and what scripts you want executed during 7 deployment lifecycle events. You have complete control and can call whatever scripts or tools you want. In this example, we're calling out to a bash script to set up Chef, and then we call another script that will kick off a community-authored Chef cookbook to install an application. There's a lot of flexibility here to use the tools and scripting you might already be using. The app spec file is YAML formatted and has the following structure. At the top here we see you have the version, which specifies what revision of the application you're working with. The OS section denotes the operating system value for this specific application. We then have a file section with the names of the files that should be copied to the instances during the deployment's install event. There's optionally a permission section that comes after the file section of the app spec file, and this applies only to Amazon Linux and Ubuntu server instances or any Linux server target. Finally, we see the hooks section, which defines really the scripts we want to run at specific lifecycle events during the deployment. Here we see we have scripts that are kicked off for stopping the application before we install, application start, and to validate the service. A lot of flexibility here. Next, once we have our app spec file and our application ready, we can prepare our deployment groups. We need to install the Code Deploy agent on each server. This can easily be automated by using a user data script to bootstrap the installation on Amazon EC2 instances, or you can build the AWS Code Deploy agent into the base Amazon machine image. Next, we'll group our target server fleets for our applications either by Amazon EC2 tag, an on-premises tag, or an auto-scaling group. Integrating Code Deploy with an auto-scaling group is a very common pattern and makes it easy to bootstrap your instances as they launch in an auto-scaling group with the correct version of your application. You can choose to divide your deployment groups however you'd like. You could split it by dev, test, staging, and production environments, for example. Finally, time to deploy. You can use the AWS CLI, an SDK, the console, or one of our partner integrations like Jenkins, Travis CI, or GitHub to kick off the deployment. Since it's API-based, we've got a number of integration partners that we'll talk a little bit more about later on. You can monitor the deployment through the Web Console, and if troubles arise, you can roll back an application to a previous revision. You just need to redeploy that revision. AWS Code Deploy keeps track of the files that were copied for the current revision and removes them before starting a new deployment. So there's really no difference between a redeploy and a rollback. It's important to note the flexibility you have when doing your deployments with AWS Code Deploy. When you create a deployment configuration, you control the setting for minimum healthy hosts. This lets you configure the speed of a deployment so you can balance availability and deployment duration. For example, you could take a more conservative deployment approach, updating one server at a time and monitoring for issues, prepared to redeploy the previous known good version if necessary. Or if it's more important your entire application server fleet gets the latest revision ASAP, you could set min healthy host to 0 and deploy to all your instances at once. Hopefully you've seen the flexibility of AWS Code Deploy and how you can really streamline your deployments. Now let's move into Amazon EC2 Container Service. Amazon EC2 Container Service is a highly scalable, high-performance container management service for Docker that lets you easily run applications on a managed cluster of Amazon EC2 instances. You can use Amazon ECS to deploy or schedule the placement of containers across your cluster based on your resource and availability requirements. You can also integrate your own scheduler or third-party schedulers to meet specific application requirements. Docker containers allow you to package your application and dependencies into a container that can easily be ported from one machine to another, preserving that fidelity of the application. This means what's running on the developer's desk is the same as what's running in production. Amazon EC2 Container Service solves the problem of scaling and running your container deployments in production. Amazon ECS eliminates the need for you to install, operate, and scale your own cluster management infrastructure. With simple API calls, you can launch and stop container-enabled applications and query the complete state of your cluster. And it doesn't matter if you want to run tens or thousands of containers, Amazon ECS will seamlessly scale to provide consistent performance. And finally, ECS is integrated with many familiar AWS services and features like security groups, elastic load balancing, and EBS volumes. Let's look at the components of Amazon ECS and how they are orchestrated to deploy your application. First, we have a container instance. This is an Amazon EC2 instance that is running the ECS agent and has been registered into an ECS cluster. The Amazon ECS container agent allows this container instance to connect to your cluster. The Amazon ECS container agent is included in the Amazon ECS optimized AMI, but you can also install it on any EC2 instance that supports the Amazon ECS specification. It's highly likely that you'll want more than one container instance, and you can provision multiple container instances in your cluster. Here we have 4. The cluster is just a logical grouping of container instances that you can place tasks on. Before we can deploy our application, we create a task definition. This is a description of an application that has one or more container definitions. When you're ready to deploy, you schedule a task. A task is just an instantiation of a task definition that is running on a container instance. In this task, we see we have 3 containers. This purple container here, for example, could be the application server component of this composed application. It's very likely that you will want to run multiple tasks. The ECS Service Scheduler for long-running tasks and application will maintain a specified number of tasks so you can scale your application. From 1 to 2, from 2 to 3, 3 to 4, and so forth. That ECS Service Scheduler will maintain the number of running tasks you specify. You can update a running service to change the number of tasks that are maintained or which task definition is used by the tasks. So if you want to update your application, you will essentially update the task definition and then update the service to use that new task definition. Let's walk through this process of updating your service to support a new version of your application. You start with the blue task definition that's currently running on your ECS cluster. We see here we have 3 tasks running based off of the blue task definition. In parallel, you'll update the task definition with a new green revision. When you're ready to deploy, simply update the service to use this new green task definition revision. The ECS Service Scheduler will start a new green task, as we see here, on an available cluster instance and perform the Elastic Load Balancer registration. During the deployment, the Service Scheduler will create a task with the new task definition, and after it reaches the running state, a task that was using that old task definition is drained and stopped. This process continues until all of the desired tasks in the service are using the new task definition. This process maintains the service's capacity during the deployment, but it does require enough spare capacity in the cluster to start one additional task. Sometimes that's not desired because you do not want to use additional capacity in your cluster. The service scheduler is flexible, and you can tweak the minimum healthy percent to specify a lower limit on the number of running tasks during the deployment. Or you can also specify the maximum percent to represent an upper limit on the number of running tasks during the deployment to enable you to define the batch size in the deployment. So there's a lot of flexibility here in how you roll out a revision of a new task definition for a currently running service. When it's all said and done, you should see that the ECS service will be fully updated and running only green tasks according to that new green task definition. Hopefully, as we've dived into Amazon ECS, you've been thinking about how you might use this for your Docker-based applications. Let's now summarize what we've seen looking at these three services to better understand when to use each service. Again, I want to reiterate that all three of these services are very flexible, and two or perhaps even all three of the services might be capable of meeting your deployment needs. That being said, each service has unique capabilities that make it a good fit for particular deployment patterns. Let's look at a decision tree here to help you focus on what service to start with. First, if your development workflow is based on Docker containers, you'll want to narrow your focus to AWS Elastic Beanstalk and Amazon ECS. If you have a standard 3-tier web application and want end-to-end management and monitoring, AWS Elastic Beanstalk is the simplest and easiest way to get started deploying. Otherwise, working with Amazon ECS directly will provide you fine-grained control for custom application architectures. If you're focused on deploying application code to virtual machines, consider AWS Elastic Beanstalk or AWS Code Deploy. Again, AWS Elastic Beanstalk is best for standard 3-tier web applications and abstracts the provisioning and monitoring of the underlying AWS infrastructure. AWS Code Deploy is an excellent building block service that can be used to update software very flexibly on any instance. I should mention here that if you are deploying on-premises, even to bare metal on-premises, you can use AWS Code Deploy. Finally, I wanted to close by juxtaposing the capabilities of the three services. This table really shows that regardless of your deployment target, there's a service that will flexibly scale to meet your needs. I wanted to call out specifically the integration capabilities of each service. For example, Elastic Beanstalk has flexible tooling, allowing integration with your CI/CD workflow. AWS Code Deploy has many third-party Git, CI/CD, and configuration management integrations. And Amazon ECS has great flexibility with container registries. These services will integrate nicely into the tools you are already using. Finally, it's important to discuss the costs about these services. For all three services, there is no additional charge for deployments in AWS. You pay for the resources you create to store and run your application. For AWS Code Deploy, though, when deploying on-premises, customers do pay 2 cents per on-premises instance update. I want to point out that we have a wealth of information available to get you started. Hopefully at this point you started thinking about which AWS service might be best for your use case. Once you've narrowed that down, take a look at some of the AWS reInvent videos we have available to stream. These will really help you dive deeper into each service and get started. And thank you so much for your time today. Hopefully, you'll be able to leave this webinar with a high-level understanding of the 3 AWS services that can be flexibly used to automate your deployments, and you can effectively choose the best service for your use case. We'll now take a quick break and then jump right into answering your questions.
Thank you, Warren, for the great presentation, and Will and Leo for answering questions throughout today's presentation. We will start addressing some of them, but apologize in advance that we might not be able to get to everyone's questions. We have about 18 minutes left, so please feel free to continue submitting questions at this time. And at the left side of your interface, you can see 3 poll questions. Your feedback can help us improve our webinar programming. So Warren, whenever you are ready, you can start a Q&A. Thank you.
Thanks so much. We're waiting to get some of the questions filtered in here. As soon as I've got those questions, I'll unmute here and answer those for you. Great, I've got the first question here. We've got a customer asking about how they can migrate from different platforms that they've used and wondering if there's a CLI tool that they can use. And there is. There is the Elastic Beanstalk command line interface. And this EB CLI provides high-level commands that makes it really simple to create, update, and monitor environments from a local repository. So it's a great tool to get you started and streamline your development workflow straight from your desktop or where you're used to provisioning from. So I'd recommend taking a look at the Elastic Beanstalk command line interface. Thanks so much for the question. We had another question here from a customer wondering if, could you use Amazon ECS for a 3-tier application? And you absolutely can. It comes down to comparing some of the capabilities of AWS Elastic Beanstalk that handles and abstracts away the provisioning and management and monitoring of the underlying infrastructure. ECS has a fully managed cluster manager, but the other components, you have a lot more flexibility in how you provision and manage your architecture. So you certainly can, but I'd say AWS Elastic Beanstalk is the quickest and simplest way to get your 3-tier web applications deployed and running. We have another question from a user saying, do I have to use a Docker container to deploy a Node.js application on EC2 container instances? So the Amazon ECS service, the schedulers that allow you to run a simple task or a long running task, you will want to encapsulate your application in a Docker container. If you want to simply deploy your Node.js application and perhaps you're not using Docker containers, I'd recommend taking a look at AWS Elastic Beanstalk, which will allow you to just provision the code, essentially upload your code and get it up and running in an application environment that is configured for you. There's another question here asking if some of the comparison charts are available on the AWS website. We will be making this presentation and the content here available to you in the coming days. We have another question here. Someone's asking if Beanstalk requires the use of RDS. You can certainly deploy AWS Elastic Beanstalk applications without RDS, or integrate your application with other AWS services for the persistent data storage on the back end, such as DynamoDB. So there's a lot of flexibility there. We have another question here regarding the pricing of these services and AWS costs. I'd just like to point you to two resources that will be very helpful. One is the product pages for each AWS service will have detailed breakdown of the pricing, but we also have a tool called the AWS Simple Monthly Calculator that is a form-driven web page where you can enter your utilization to estimate your costs for the service. We have another question here with regards to what are some of the advantages of using the RDS service in conjunction with AWS Elastic Beanstalk. Some of the key advantages are how the RDS service is a fully managed service where the provisioning of the database, the backups, the restores, the updates of the underlying database application are managed for you, so that way you don't have to deal with the heavy lifting. And you can really focus on how you're optimizing the database for your application and focus on the higher level value-added tasks. Scrolling through here, looking for any last couple questions, feel free to ask those. We'll try to get those answered.
I've seen lots of attendees right now have raised their hands. So, Dennis, Greg, Fred, Sayam, and Anne, please feel free to submit your questions in the Q&A pod. We'll be able to see those questions coming in. Thank you.
Here, the question is, if I use Beanstalk to deploy my application into multiple instances, but each instance has its own minorly different configuration, how can this be done through Beanstalk? Elastic Beanstalk supports this through the configuration of your individual environments. So your environment configuration allows you to easily customize the environment at the same time you deploy your application version by including a configuration file with that source bundle. So this allows you to configure things such as the environment variables and other unique environment components that are necessary for your AWS Elastic Beanstalk environment. So perhaps your staging environment might point to a different database than your production environment, or integrate with other services or third-party integrations. You can specify that and configure that for each environment. Here's another question I'm taking a look at. They're asking, does Elastic Beanstalk allow installation of additional software to the server instance? So Elastic Beanstalk allows you to have full control over the individual instances. So hypothetically, if you wanted to connect to one of these instances and install software, you could, but that's not really a deployment pattern we'd recommend, because if you were to auto-scale and a new instance were to launch and be bootstrapped, those one-off changes wouldn't be available in the environment. So you certainly do have full control and can take control over the resources, but I would say not a recommended pattern. And you should try to build that into your environment configuration if possible. And one final question here. The question is, why would I choose ECS over Elastic Beanstalk? So again, remember, AWS Elastic Beanstalk abstracts away the end-to-end management and provisioning of the underlying infrastructure, such as the Amazon EC2 instances, the auto-scaling groups, all that underlying infrastructure you don't necessarily have to worry about. If you want a cluster management solution, you can leverage Amazon ECS to run a cluster to run your Docker containers, and then have really fine-grained control over building an architecture that will hook together different services, different containers, different tasks, and overall be very flexible, but you will get more into the provisioning and management of the infrastructure. Again, thanks so much for those questions.
Great. I'd like to extend a special thank you to our presenter, Warren Settner, for his time and a great presentation, and Will Sinclair and Leo Shatnovetsky for answering the audience questions. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email aws-webcasts@amazon.com. Your feedback helps improve our webinar programming. Thank you to our audience for taking the time to join us today. Enjoy the rest of your day.